Welcome to Study Loop.
So if you want small voltage drop or the minimum voltage drop across 2 microfarad capacitor, so then we can see that we know the equation V equals Q over C, and from there we can tell that if the capacitance is very small, that means our voltage drop will be very high. So if we look at the diagram here, what we did here is we took the smallest capacitor and connected that in series with the battery, and what that does is that creates a huge voltage drop across C2. Now, since we want the minimum voltage drop across C1, so what we can do is we can make this guy the denominator bigger so that we get minimum voltage drop. And to do so, we need to put C1 parallel to C3. So these two are the highest. C3 is the highest, and C1 is the second highest capacitor among three. So that's why we are putting these two guys, this one and this one, in parallel so that we get the highest value in the denominator, and that will give us the minimum voltage drop. So let's actually try to solve it mathematically. So we'll have C equivalent, which is equal to 1 over C2. So we're trying to solve this circuit, plus 1 over C1 plus C3. So C1 plus C3 is the equivalent circuit of these two guys since they're in parallel, and then C equivalent will be uh, the equivalent circuit of C1 and C3, reciprocal of that, plus the reciprocal of C2, and that should give us the reciprocal of C equivalent. And from there, C equivalent will be C2 times C1 plus C3 divided by C1 plus C2 plus C3. And our Q equivalent is going to be C equivalent times V naught, where V naught is the voltage of the battery, and V2 will be Q2 by C2. And since C2 is in series connection with this guy, so that means C equivalent will be equal. So the charge in C equivalent should be equal to the charge in C2 and charge in the equivalent resistance of C1 and C3. So that means it's gonna be Q equivalent divided by C2, and since we know that V1 is the we can say that V1 is the voltage drop, the desired voltage drop that we want. And if we say that V2 is the voltage drop across C2, that means V1 should be equal to the total voltage minus the voltage drop across C2. So we can substitute this value right here. So it's going to be V naught minus Q equivalent by C2, and that should give us an expression like this: C2 C1 plus C3 divided by C1 plus C2 plus C3 times V naught, the whole thing divided by C2. And if we solve for it, we'll get something like C2 divided by C1 plus C2 plus C3 times V naught. And we know all the values they are given, and we should get something like 2.8 volts. So just to be clear, C2 is, in our case, C2 is 1.5 microfarad, C1 is 2, and C3 is 3 microfarad, C3 is 3 microfarad, and V naught in our case is 12 volts. Thank you.